Maritime Incident and Accident Investigation. Part 3 of the lecture. Root cause analysis. Tip: root cause analysis should be conducted for every occurrence, regardless of severity or complexity. Minor incidents often foreshadow more serious events. Accidents, however serious, are symptoms of a larger problem within a system. Though accidents generally stem from many causal factors, correcting the symptoms of a problem does little to prevent the possibility of a similar or more severe accident. To identify and treat the true ailment in a system, the root causes of an accident must be identified. Root cause analysis is any methodology that identifies the causal factors, including management systems deficiencies, which, if corrected, would prevent recurrence of the accident. Simply stated, the root cause is the underlying reason that answers the investigator's question, why? In this way, root cause analysis does not only apply to a specific accident or occurrence, but is intended to have generic implications for lessons learned to a broad group of vessels or vessel operations. Once several, or all, of the recommended core analytic techniques have been performed, the accident investigation team should have a broad understanding of the accident's events and conditions, along with a fairly extensive list of suspected causal factors. A root cause analysis is performed to define the list of causal factors and categorize each according to its significance and impact on the accident. This section discusses analytical tools that can help accident investigators determine the root causes of the accident. Root cause analysis is not an exact science and therefore requires a certain amount of judgment. A root cause is a causal factor that, if corrected, would prevent recurrence of the accident. Root causes involve both local problems, localized, or problems within the entire system, systemic, that allow or create deficiencies that cause or could cause unwanted occurrences. Root cause analysis is a systematic process that uses the facts and previously performed analyses to determine the underlying reasons for the accident. In accident investigations, finding root causes is prerequisite to the development and implementation of corrective and preventive measures. The intent of this analysis is to identify and address only those root causes that can be controlled within a system being investigated. This would exclude events or effects that cannot be reasonably anticipated or controlled, such as earthquakes, tornadoes, floods, and other natural disasters. Core analytic techniques, such as events and causal factors, change, and barrier analysis, provide answers to an investigator's questions regarding what, when, where, who, and how. Root cause analysis is primarily performed to resolve the question, why? There may be more than one root cause of a particular accident, but probably not more than 3 or 4. If more are thought to exist at the conclusion of the analysis, the team should re-examine the list of causal factors to determine which causes can be further combined to reflect more fundamental, root causes. Tip: in any accident, there may be a series of causal factors, one leading to another. One of the most important responsibilities of the investigation team is to pursue each factor in the series until the team is assured that actual root causes are identified. Regardless of which technique is used, the main focus of the team should be finding concise and valid root causes that address the fundamental system deficiencies that led to the accident. To initiate a root cause analysis, the facts surrounding the accident must be known. In addition, the facts must be analyzed using other analytic methods to ascertain an initial list of causal factors. A rather exhaustive list of causal factors must be developed prior to the application of root cause analysis to ensure that final root causes are accurate and comprehensive. Tip: if a root cause analysis is attempted before all the significant facts are known or the full spectrum of causal factors is determined, it is likely that the real root causes will not be discovered. To acquire needed information, Investigators should examine the evidence collected from the accident scene, witness statements, interviews, and facility documents to determine what additional information will be needed for the particular root cause technique they are performing. Root cause analysis can be performed using computerized or manual techniques. Regardless of the method, the intent is to use a systematic process for identifying root causes. It is important that the accident investigation team work together to determine the root causes of an accident. The primary mission of the investigative team is to identify the root causes of an accident so that judgments of need can be prepared and appropriate corrective measures can be developed and implemented. Therefore, all team members must participate in the root cause analysis. It cannot be left solely to the lead investigator or to a single member of the team. Tediogramming. Tediogramming is a technique used to identify both the root causes of an accident and the level of line management responsibility associated with contributing and root causes. The team uses the tier diagram to hierarchically categorize the causal factors derived from an events and causal factors analysis. The diagram is usually divided into 6 tiers, numbered 0 through 5, which represent organizational responsibility ranging from the worker level to upper management. In a series of steps, causal factors are evaluated as potential root causes and linked to a level of responsibility in the line organization. Tier table. Tier 5, Senior Management. Responsibilities for causal factor consideration. Policy development, awareness, involvement, lessons learned/feedback, contract terms/conditions. Questions for considering in assigning causal factors. Did senior management establish safety-related policies to promote a safe work environment? Was senior management involved in the site-wide prioritization of work? Did senior management institutionalize the stop work authority philosophy? Was senior management aware of previous safety-related incidents? Was senior management visibly involved in assessing safety-related policy implementation? Did senior management use lessons learned/feedback from previous incidents to prevent future similar incidents? Did senior management condone or allow contract terms and conditions that were not consistent with safe working conditions, for example accelerated schedules, reduced quality requirements? Tier 4, Middle Management. Responsibilities for causal factor consideration. Policy implementation, plans and programs, awareness, involvement, feedback. Questions for considering in assigning causal factors. Did management implement policy through plans and programs development? Was management aware of the status of plans and program implementation? When problems occurred, did management request feedback on the nature of problems? Did management have a system for monitoring and measuring organizational performance? Was stop work authority communicated to the organization? Was management involved in the development and implementation of corrective actions? Tier 3, Lower Management. Responsibilities for causal factor consideration. Procedure development, plans and program implementation, awareness, involvement, feedback, corrective actions. Questions for considering in assigning causal factors. Were required procedures developed and kept current to assure a safe work environment? Did management implement required programs for worker safety? Was management sworn of problems regarding procedure implementation and compliance? Was management involved in the work planning, control, and execution process? Did management have a system for eliciting feedback on work-related hazards? Did management have a system for identifying and disseminating work process lessons learned? Was stop work authority defined for first-line supervisors and their staff? Did management take timely corrective actions when problems occurred or were identified? Tier 2, Supervision. Responsibilities for causal factor consideration. Work instructions, work environment, procedures, training, communications, tools/equipment, corrective actions. Questions for considering in assigning causal factors. Were the supervisor's work instructions adequate to allow the work to be performed safely? Was the work environment safe? Were required procedures provided or communicated to the worker by supervision? Did the supervisor provide the required training to the worker? Did the supervisor discuss job hazards with the worker prior to starting work? Did the supervisor define stop work authority for workers? Did the supervisor confirm the readiness to perform work prior to the execution of work? Did the supervisor provide the worker with the proper tools and equipment to perform the work safely? Did the supervisor provide feedback to management on prior incidents and/or safety concerns? Did the supervisor implement timely corrective actions based on previous incidents? Tier 1, Worker Actions. Responsibilities for causal factor consideration. Procedures, training, communications, understanding, experience, direct cause of occurrence, knowledge, skills, abilities, human error, tools/equipment. Questions for considering in assigning causal factors. Was the work covered by procedures? Was the worker trained on the procedures? Were communications adequate to inform the worker of any hazards? Did the worker understand the work to performed? Was the worker knowledgeable of the type and magnitude of hazards associated with the work? Were the worker's knowledge, skills, and abilities adequate to perform the job safely? Was worker error a causal factor in the accident? Did the worker have stop work authority? Did the worker understand she/he had stop work authority? Did the worker have the right tools and equipment to perform the job safely? Tier 0, Direct Cause. A tier table or diagram is helpful in identifying and analyzing root causes because it helps the team organize and categorize the causal factors identified on the events and causal factors chart. Causal factors into higher level, fundamental organizational deficiencies, root causes, provides a structured and repeatable approach for assigning management responsibility for each causal factor, forces the team to assign responsibility for root causes, from which appropriate judgments of need can later be developed, assists the team in visually and physically organizing significant causal factor data. Before initiating a root cause analysis using the tier diagram method, the investigator should be satisfied with the results of the events and causal factors analysis. In addition, the team must have a solid understanding of the line organization responsible for the activities associated with the accident. Getting started. Once the events and causal factors analysis is complete, a number of causal factors are noted on the events and causal factors chart. These will be the input to the tier diagram and root cause analysis. Provided below are step-by-step instructions for completing the root cause analysis using the tier diagram. Guidelines and other reminders follow the instructions. Step 1. Identify significant events/conditions. Review the causal factors listed on the events and causal factors chart to focus only on significant events or conditions, that is, causal factors. Step 2. Assign letter designators. Starting at the beginning of the chart, assign a letter to each causal factor, A, B, C, and so on an adhesive note. Place the same letter designator on the actual chart where that causal factor is affixed. Later, the analyst will remove the adhesive notes and place them on the tier diagram. By noting where the causal factor originated, the analyst can easily return to the event chain if a question arises during the root cause analysis. Step 3. Develop tier diagram framework. Using tier table as a model, Create a tier diagram with the number of tiers commensurate with the line organization being examined. The grid can be drawn on large butcher paper, a whiteboard, or any other surface large enough for displaying to the team members. For the purposes of this section, a typical organization with 6 tiers is assumed. A review of organizational charts, work control logs, and other such documentary evidence may be helpful in completing this step. Step 4. Begin with Tier 0. Remove the direct cause statement, adhesive note and place it in Tier 0, direct cause. Remove all other causal factor adhesive notes and place them in Tier 1, worker actions. Step 5. Evaluate Tier 1. Beginning with causal factor, ask whether the worker actions Tier 1 is the organizational level responsible for this causal factor, that is, can this causal factor be attributed to the worker S involved in the accident? Use the categories and questions listed in Table 7-14 as guidance in completing this step. Step 6. Evaluate Tier 2. If the causal factor can be attributed to the worker, ask whether the causal factor is solely attributable to the worker actions tier. Did the worker's supervisor have any responsibility for this causal factor? If not, leave the causal factor in Tier 1. If the supervisor had any responsibility for this causal factor, write a letter in Tier 1 and physically move the causal factor adhesive note to Tier 2. Step 7. Evaluate other tiers. Continue a similar line of inquiry about the causal factor at each successive tier until satisfied that the causal factor is placed in the tier commensurate with the highest level of responsibility or authority for it. Again, as a causal factor is moved to higher tiers, note the letter designation in the tier from which it is moved. For example, if responsibility for causal factor A is found to reside with upper management, the letter A should appear in Tiers 1 through 4, with the actual adhesive note placed in Tier 5. Step 8. Repeat for each causal factor. Repeat steps 1 through 7 for each causal factor previously placed in Tier 1 of the diagram. Step 9. Identify linkages. After arranging all the causal factors on the tier diagram, examine the causal factors to determine whether there is linkage between 2 or more of them. For example, are 2 or 3 causal factors similar enough to indicate poor conduct of operations? Or perhaps several causal factors are related to a lack of worker training. If linkages exist, group the adhesive notes at the highest level where a linkage occurs. For example, if causal factors B and F single quote in Tier 3 are related to causal factor H in Tier 4, remove B and F, noting their location, and affix them to H in Tier 4. Next, if one of the causal factors statements accurately describes the commonality among the grouped causal factors, let a causal factor represent the grouping. If not, write a causal factor statement that captures the common theme of all the causal factors in that particular grouping. This statement becomes a potential root cause. The investigative team members should continue to examine all of the causal factors until they are satisfied that all applicable linkages have been made. Step 10. Identify root causes. Evaluate each of the causal factor statements that now appear on the chart. Compare each statement to the definition of a root cause to determine whether it appears to be a root cause of the accident. This step will generally involve a great deal of discussion among team members. Tip: if a causal factor does not meet the criteria for a root cause, do nothing. It remains a contributing cause of the accident. If a causal factor, singly or representing a group, meets the criteria for a root cause, denote it as such either using the letters RC, root cause, or by some other means. You may find that you need to create a root cause statement based on one or more causal factors. If so, write a summary causal factor statement and place it on the appropriate tier. The team may choose to add a third column, root causes, to the tier diagram. The advantage of adding this column is that moving the root cause statements makes them stand out along with the associated level of management responsibility. The root cause analysis may reveal causal factors that are not on the events and causal factors chart. These should be added to both the events and causal factors chart and the tier diagram to assure that they are consistent and reflect all of the causal factors as a basis for root cause analysis. Step 11. Simplify root cause statements. There may be more than one root cause of a particular accident, but probably not more than 3. If there are more than that at the end of the tier diagram analysis, the team should re-examine the list of root causes to determine which ones can be further combined to reflect more fundamental deficiencies. When the team is satisfied that the root causes have been accurately identified and the number of root causes is not excessive, the root cause analysis is complete. The team should capture the essence of the root cause analysis for the accident investigation report, noting the direct, contributing, and root causes of the accident in order to develop judgments of need. Guidelines and reminders. Root causes may be found in any of tiers 1 through 5. However, they are generally found in higher tiers because that is where managers are most responsible for directing and overseeing activities. The root cause of an accident can be found at the worker level of the tier diagram if, and only if, the following conditions are found to exist. Management systems were in place and functioning, and provided management with feedback on system implementation and performance. Management took appropriate actions based on the feedback. Management, including supervision, could not reasonably have been expected to take additional actions based on the responsibilities and authorities. Root causes can be found at more than one level of an organization. For example, one root cause may be attributable to Tier 3, while 2 other root causes are attributable to Tier 5. Root causes are generally attributable to an action or lack of action by a particular group or individual in the line organization. Each corporate organization is considered separately for its responsibility in the accident. Consequently, the results of one tier diagram may be the input of another. For example, if the upper management of an outside contractor was responsible for a particular root cause, the shipping company management may share responsibility for that particular root cause. There may be a deficiency in the directives from the shipping company, insufficient oversight, or some other responsibility that was inadequately fulfilled. Risk identification and evaluation. Risk assessment is a process used in safety management to identify, measure and determine what hazards can be anticipated during each stage of any work or project to be undertaken. This is a proactive reaction to enhance safety. In contrast, incident investigation is a reactive action to determine the underlying and root causes to the incident or accident. The purpose of an incident investigation is also to formulate and implement preventive measures to avoid recurrence. Remedial immediate actions. Eliminate the hazard. If the hazard can be eliminated, then it will not be necessary to be concerned with safeguards to protect personnel from the hazard. For example, if dust generation during loading can be eliminated, then it will not be necessary to worry about trying to control it or plan responses to dust explosions. If the storage of flammable materials in the galley can be eliminated, then there will be less concern about fires. This is an example of engineering the hazard out of the workplace. In some cases, it is impractical to eliminate the hazards. For example, it is impractical to eliminate all heat sources from the galley to prevent fires. It is impractical to eliminate flammable materials on an LNG carrier. In these cases, it will be necessary to move to the next level of dealing with hazards. Make the system inherently safer, more reliable. Assuming the hazard is present, it is necessary to take actions to make the system inherently safer and/or more reliable. This could include minimizing inventories of a material, moving from single-hull to double-hull designs, widening and deepening waterways, using lower speeds in close maneuvering areas, and installing equipment with greater design margins. Prevent the reoccurrence of the incident. Preventing the occurrence of the incident can involve designing interlocks that largely prevent errors, installing cargo hold tops with greater strength, installing better navigational equipment and navigational aids, using maintenance procedures, supervision of personnel, management systems to control work processes, and developing airproofing methods for equipment. Detect and mitigate the loss. Here, actions are recommended to do a better job of responding to the loss once it happens. For example, fire detection and firefighting equipment help detect and then mitigate the loss. Trouble alarms, failure finding maintenance and routine rounds are methods used to detect problems with the machinery and equipment. Audits, record reviews and supervision are used to detect issues with the behavior of individuals. Emergency response activities are included in this category. Depending upon the situation, the organization may choose to implement a number of different types of recommendations. For example, they may reduce the amount of flammable raw materials stored on board, make the system inherently safer, improve general housekeeping in the area, prevent the occurrence, and improve the training drills for the fire team, mitigate the loss. In most cases, the potential for an incident cannot be eliminated, but its probability of occurring can be minimized. If it does happen, then the consequences of the incident should be minimized. To do this, multiple levels of recommendations may be required. Investigation report compilation. Conclusions and recommendation. Draft Marine Safety Investigation Reports. The Marine Safety Investigating State S shall send a copy of a draft report to a substantially interested state to allow the substantially interested state to make comment on the draft report. Marine Safety Investigating State S are only bound to comply with paragraph above where the substantially interested state receiving the report guarantees not to circulate, nor wish to circulate, publish or give access to the draft report, or any part thereof, without the express consent of the Marine Safety Investigating State S, or unless such reports or documents have already been published by the Marine Safety Investigating State S. The Marine Safety Investigating State S are not bound to comply with above requirements if the Marine Safety Investigating State S request that the substantially interested state receiving the report to affirm that evidence included in the draft report will not be admitted in civil or criminal proceedings against a person who gave the evidence, and the substantially interested state refuses to provide such an affirmation. The Marine Safety Investigating State S shall invite the substantially interested states to submit their comments on the draft report within 30 days or some other mutually agreed period. The Marine Safety Investigating State S shall consider the comments before preparing the final report, and where the acceptance or rejection of the comments will have direct impact on the interests of the state that submitted them, the Marine Safety Investigating State S shall notify the substantially interested state of the manner in which the comments were addressed. If the Marine Safety Investigating State S receives no comments after the 30 days or the mutually agreed period has expired, then it may proceed to finalize the report. The Marine Safety Investigating State S shall seek to fully verify the accuracy and completeness of the draft report by the most practical means. Marine Safety Investigation Reports. The Marine Safety Investigating State S shall submit the final version of a marine safety investigation report to the organization for every marine safety investigation conducted into a very serious marine casualty. Where a marine safety investigation is conducted into a marine casualty or marine incident, other than a very serious marine casualty, and a marine safety investigation report is produced which contains information which may prevent or lessen the seriousness of marine casualties or marine incidents in the future, the final version shall be submitted to the organization. The Marine Safety Investigation Report referred in paragraphs 14.1 and 14.2 shall utilize all the information obtained during a marine safety investigation, taking into account its scope, required to ensure that all the relevant safety issues are included and understood so that safety action can be taken as necessary. The final Marine Safety Investigation Report shall be made available to the public and the shipping industry by the Marine Safety Investigating State, S, or the Marine Safety Investigating State, S, shall undertake to assist the public and the shipping industry with details necessary to access the report, where it is published by another state or the organization. Draft and Final Report. Marine safety investigation reports from a marine safety investigation should be completed as quickly as practicable. Where it is requested, and where practicable, the Marine Safety Investigating State, S, should send a copy of a draft Marine Safety Investigation Report for comment to interested parties. However, this recommendation does not apply where there is no guarantee that the interested party will not circulate, nor wish to circulate, publish or give access to the draft Marine Safety Investigation Report, or any part thereof, without the express consent of the Marine Safety Investigating State, S. The Marine Safety Investigating State, S, should allow the interested party 30 days or some other mutually agreed time to submit their comments on the Marine Safety Investigation Report. The Marine Safety Investigating State, S, should consider the comments before preparing the final Marine Safety Investigation Report, and where the acceptance or rejection of the comments will have direct impact on the interests of the interested party that submitted them, the Marine Safety Investigating State, S, should notify the interested party of the manner in which the comments were addressed. If the Marine Safety Investigating State, S, receives no comments after the 30 days or the mutually agreed period has expired, then it may proceed to finalize the Marine Safety Investigation Report *, where it is permitted by the national laws of the state preparing the Marine Safety Investigation Report. The draft and final report should be prevented from being admissible in evidence in proceedings related to the marine casualty or marine incident that may lead to disciplinary measures, criminal conviction, or the determination of civil liability. At any stage during a marine safety investigation, interim safety measures may be recommended. Where a substantially interested state disagrees with the whole or a part of a final Marine Safety Investigation Report, it may submit its own report to the organization. Format of the report. There are two aspects to final casualty reports: the actual report and the requirements to report to the International Maritime Organization. The actual report. The code sets out, paragraph 14, a basic report layout. This layout is logical and helps develop a structured report. Circumstances may dictate a variation on format, but whenever possible the final report generated by the investigation team should contain summary. This part outlines the basic facts of the casualty, stating whether any deaths, injuries or pollution have occurred as a result. It may contain the main conclusions in a summary form. Factual details. This part includes the identity of the ship, flag, owners, managers, classification society, as well as the relevant basic ship details, type, size, power, crew, etc. Factual narrative. This section sets out in plain terms the established facts of the casualty. It is necessary here to clearly separate the established fact from conclusions and presumptions. The section needs to be written with care and confine purely the facts which are established with certainty. There will inevitably be gaps, but the investigator should avoid trying to fill gaps in this section. That can be done in the analysis section. Any reader should be able to establish from this section exactly what events are established as occurring with certainty in their chronological order. Analysis and comment. In this section, the investigator is free to take the facts collected and analyze them, adding in expert analysis and drawing together different facts to reach supportive conclusions on the causes behind the casualty. The basic arguments behind each conclusion need to be set out in this section, and each conclusion needs to draw on facts and demonstrate its basis. It is always possible that the investigator is certain of some elements, but the investigation is unable to find sufficient facts to firmly prove those elements. It is permissible in this section to state this, and expressions like, on the balance of probabilities the following is concluded as the reason for, can be used when there is no alternative and provided that there is sound evidence and technical analysis pointing towards reaching this conclusion. The section should end with a set of conclusions derived from the analysis, and noting where the conclusions are reached by argument without firm evidence. Analysis of causal elements. A section, or sections, analyzing and commenting on causal elements, both mechanical and human. Similar comments apply to this section as with the preceding section. Recommendations. A set of recommendations addressed to flag state, class, owner, crew, etc. as appropriate and derived from the analysis conclusions, where the analysis and conclusions suggest any changes that could prevent the recurrence. Reports to IMO. There is an obligation arising from Regulation 1/21 of SOLAS for flag states to report casualties to the International Maritime Organization. Submission of reports to IMO under Regulation 1/21 of SOLAS is not required if the flag state judges that the investigation has not demonstrated a need for change in existing international regulations. Indeed, IMO member states are obliged to demonstrate a compelling need for a change in any regulation before an item may be placed on the agenda of an IMO committee. However, it is also true that there is a general perception now that all casualties should be reported regardless of the strict interpretation of Regulation 1/21. IMO Circulars MSC Circular 827, MEPC Circular 333 of December 1997 set out harmonized reporting procedures developed by the International Maritime Organization for flag states to fulfill their obligations under the conventions. The circulars provide standard reporting formats in which the basic details can be inserted for submission to IMO, and also set out an agreed time frame for the submission of various reports. In many investigations there will be a number of other interested parties who will press for information as the investigation process goes on. Conclusions and recommendations. Developing conclusions, recommendations and judgments of need. Conclusions and recommendations/judgments of need are key elements of the investigation that must be developed. Conclusions. Conclusions are significant deductions derived from the investigation's analytical results. They are derived from and must be supported by the facts plus the results of testing and the various analyses conducted. Conclusions may include concise statements of the causal factors of the accident determined by analysis of facts, be statements that alleviate potential confusion on issues that were originally suspected causes, address significant concerns arising out of the accident that are unsubstantiated conclusion or inconclusive, be used to highlight positive aspects of performance revealed during the investigation, where appropriate. When developing conclusions, the investigator should Organize conclusions sequentially, preferably in chronological order or in logical sets, for example, hardware, procedures, people, organizations. Base conclusions on the facts and the subsequent analysis of the facts and include only substantive conclusions that bear directly on the accident, and that reiterate significant facts and pertinent analytical results leading to the accident's causes. Keep conclusions as short as possible and, to the extent possible, limit reference citations, if used, to one per conclusion. Tip: the process of determining conclusions seeks to answer the questions what happened and why did it happen. Recommendations: depending on the size of the investigation, its scope, the makeup of the investigative team, the media coverage or lack thereof, and the appointing authority, and its ability to mandate or prescribe changes, most investigations will lead to recommendations which may be prescriptive in nature. These differ from judgments of need, which are described below. They must, however, be stated in a clear, concise, and direct manner, based on the facts/evidence, stated so that they can be the basis for corrective action plans. Judgments of need. Judgments of need are the managerial controls and safety measures determined by the investigator to be necessary to prevent or minimize the probability or severity of a recurrence. Recommendations or judgments of need should be linked to causal factors and logically flow from the conclusions. Like recommendations, they should be stated in a clear, concise, and direct manner, based on the facts/evidence, stated so that they can be the basis for corrective action plans. Judgments of need should not be prescriptive corrective action plans or recommendations, nor should they suggest punitive actions. Should not include process issues, for example, evidence-controlled preservation of the accident scene, readiness, unless these issues have a direct impact on the accident. These concerns should be noted in a separate memorandum to the appointing official. An interactive process is the preferred approach for generating judgments of need. That is, investigators should work to review causal factors and then begin generating a list of judgments of need. These judgments should be linked directly to causal factors, which are derived from facts and analysis. Tip: team members should work together to derive judgments of need to assure that the merits and validity of each are openly discussed and that each one flows from the facts and analysis. One method for ensuring that all significant facts and analytical results are addressed in the judgments of need is to develop displays linking judgments of need with facts, analysis, and causal factors. Investigators sometimes find it useful to display these elements on the walls or a whiteboard or chalkboard. Figure below demonstrates how this information can be arranged to provide an ongoing assessment of linkages among the R elements. It portrays the concept of requirements verification analysis. Using this approach, the investigators can identify gaps in the data where a clear, logical flow among the four elements is missing. The investigators can use this information to determine whether judgments of need are supported by linkages connecting the facts, results from analysis, and causal factors. Tip: if a judgment of need cannot be clearly linked to causal factors derived from analyses of facts, exclude it from the report. Guidelines for writing judgments of need. Clearly identify organizations that need to implement actions to prevent recurrence of the accident. Avoid generic statements and focus on processes and systems, not individuals. Focus on causal factors. Be specific and concise. Avoid vague, generalized, broad brush sweeping solutions. Do not tell management how to do something, simply identify the need. Present judgments of need in a manner that allows a specific organization to translate them into corrective actions sufficient to prevent recurrence. Format of sample report template. Evaluate the investigation process. Types of evaluations and communications. Two types of evaluations can be performed: an evaluation of the investigation process and an evaluation of a specific investigation. A final critique of the investigation process helps identify any weaknesses in the current investigation and identify suggestions that will improve future investigations. Ideally, all of the individuals participating in the investigation should participate in the critique. Usually, the process involves two methods of communication. The first is a critique meeting. During the meeting, members share the pluses and minuses of each aspect of the investigation process and how it worked during this particular application. Most organizations find an informal tone to the meeting works best. However, each participant should be specifically asked for his or her input. The second method is one-on-one feedback with the team leader or incident investigation program manager. This provides a method for those individuals who are not comfortable sharing issues during the meeting to communicate their concerns. Example critique questions. The following are example critique questions. How well did the investigation satisfy its goals and objectives? What investigation activities went well? What improvements could be made? What additional training would be useful to promote more effective investigations? What additional resources should be available to support investigations? What items caused inefficiencies in the investigation? Follow-up of critique process. Weaknesses and recommendations for improvement should be passed on to the Incident Investigation Program Manager for incorporation into the incident investigation process. Some organizations score a sample of their investigations against a scorecard. The scorecard awards points for meeting specific criteria. Trending of the scores can provide an indication of the performance of the investigation program. The scores can also provide feedback to the investigators to improve their performance. The causal factor, root cause and recommendation checklist, along with the report checklist and investigation checklist, can be used as a starting point for developing a scoring system. End of lecture. This learning material is copyright by Maritime Bureau of Africa, 2020.